It's ready? Okay. Okay, so this talk is about using metadata in decentralized applications, something that has been called semantic Ethereum. And well, I guess I'll start with who am I? I'm Jamie Pitts. I help out at the Ethereum Foundation. At one time, I was very much a fan of the semantic web. It went on for a long time, and then I discovered Ethereum, so I'm happy that that changed. But it's in my heart. The semantic web is a very interesting effort. A lot of resources went into it, and I think we can learn from it, even though it didn't quite pan out the way that Tim Berners-Lee wanted it to pan out. So if you're going to start talking about semantic web, you should start talking about metadata. And this is ironically the Google info box definition. It's data that describes other data. Simple as that. We often use it in our web applications, but we might use it for SEO purposes. But there's a real depth to it, and there's a real theory behind it. And there's a world of developers, and especially standards developers working on it, particularly with the W3C. And the notion is that it just goes deeper and deeper, and data can be connected together to everything else. So the semantic web was this visionary project by Tim Berners-Lee in the aughts. And I think he first wrote about it or initiated it in 1999, 2000, thereabouts. And so the thing about Tim Berners-Lee, he developed the original web. And so because he did that, there's a tendency, at least in my heart, to really listen to what he has to say. And so I really tuned in. I'm like, this is very interesting stuff. So he started with the current web, and he said, we can take just what's content and actually turn it into data, and that we know who posted this data, and that's a web of trust. You can form trust, and you can analyze that data knowing the source of that data. And then in the deeper level, it's a web of meaning, that some meaning can be derived from it, and a whole world of services can emerge from there. And the effort has been going on for a long time, and it's still going on. They're still working on it. And so a key aspect is to establish ontologies, which is how structuring the information, especially relationships between different kinds of objects. It's really similar to how you would design a database in a web application. And the key is, once you've established ontologies, you publish data about those ontologies in normal web or otherwise, and that data would refer to the ontology, so that if you have a person, that data would refer to the ontological information about the person. So you can reason about it. And obviously, this is not for normal users. Like, you and I are not going to be browsing the semantic web, enjoying that, unless we really have an appetite for pain. But it's really for machines. And essentially, all these relationships, which are loose, they're not enforced, the relationships between all these points of data, because it's all over the web, it could create a gigantic graph database. And if you think about Google, what Google does, it saw the web itself as a graph, and that's the origin of its success. And the notion is that if you publish this data, the entire web could become a database. No index on that database, but that's the job of aggregators. And you can see from this diagram how things might be connected, and it could just go on and on and on as things refer to each other. So here's a cool standard. It's called Sparkle, and it's published by the W3C, and it's how you can query this graph data in a SQL-like manner. It's, you can see from it, it's not elegant like SQL, but it's kind of alluring to see that, and I was really interested in that when it came out. Now, there's a conundrum to this. When you loosely declare stuff, it's ambiguous, but if you go really deep on describing things, that's very burdensome for developers. It's burdensome for normal people. to create these ontologies, to create this data. And obviously, the semantic web did not go big. It didn't take over the universe. It didn't become anything like the phenomenon that we're wrapped up in. But the thing is, it developed all these standards, lots and lots of standards, some of them very, very ornate, but nothing that a user would know, hey, this is the semantic web I'm using, right? Unless you're like a domain expert. And there's a famous article written by Cory Doctorow that calls it meta crap. And he just goes into how, because of the nature of human beings declaring this data, there's going to be lies, inaccuracies, all those things. All those things we're quite used to on the internet in general. And so he's a big doubt. He's a big doubter of this. But the thing is, metadata is widespread. If you're a web developer, you know you're constantly thinking about it for SEO purposes and just in general to be a good citizen. So here's a couple of good examples of actual semantic web standard data being used. When you get your email about your airline ticket, Gmail is actually interpreting semantic web standard data and rendering that. And even GitHub Actions, those little actions there, Google has published a way that you can, using semantic web standards, create a GitHub style, those little nice drop downs. And of course, Google has these info boxes, which are kind of controversial Wikipedia-like info boxes that comes from harvested semantic web data. So if you think about when W3C standards are called recommendations, so what do they provide? What do these recommendations provide? One is linkage. Things are linked together. And think about a link on a web page. Pretty much universally we'll know what that is. But there's a specific way semantic web data or metadata links to other data. Link refers to that ontology, refers to other related data. So that's linkage. Another one is descriptive. Descriptive meaning, that's a second thing it provides. Another key is structural meaning. You can actually create an ontology that has all these special relationships and just gets extremely ornate. It's like you can just get lost in it, and you can define something in the real world with just excruciating level of detail of a potential object, and it's invalid. Like you could define ontology for microphones, and you could just go to town on that. I mean, I'm sure somebody has developed an ontology for microphones for an industry-specific application. Now, if you do these things, if you have those three things it provides, what does it lead to? As a publisher, you have lots of options. The data is structured, so it's much more easy to aggregate. Google's advantage in any search engine is they just have huge engineering resources, huge computational power, and they apply statistics and they can analyze things. And that's because the data that they're analyzing is so messy. And that's how, that's a big part of their power position, in my opinion. Being that the semantic web data might be there, it creates a potential value chain, much like in Ethereum ecosystem that we see in contracts. The semantic web was potentially going to you can layer new interesting things on top of it, and then new services coming from that. And so how does metadata do this? How does semantic web standard data do this? Highly formalized assertions. So okay, you're going to make some metadata about a microphone. You're going to assert okay, that's colored black, that's plastic, that's this and that. All these different facts about it, those are assertions. And those will be structured. The data format is called RDF. It's a graph. It has a really special format. It's mentally taxing to even grok RDF. It's very interesting. I would recommend it, but not to develop in it. And it's layered on top of the current web. Tim Berners-Lee wanted it to be decorating the current web, so it can piggyback on the current web, and it has been doing that. If you open up any web page and look at the source, there's tons of metadata all throughout that thing, either declared as a block of some data, or inside the HTML tags. It's just woven in there, and you can kind of see it, how it's annotating what's in the web page, like tables of data. Now, one thing about semantic web data that's really interesting is, say an API has a rigidity about it. You expect an API to have these results, and it's going to be like person and have these fields. Semantic web data allows you to express all kinds of concepts as long as you're referring to the ontological aspect properly. You can mix in all kinds of data. You have a person, and you can put a dog in there. You can just put all kinds of stuff in there, and the aggregator could be able to, in a comprehensible way, query that data, even though it's just completely mixed up with all kinds of different objects. That's why it's so excruciating in terms of needing structure for that data. So here, I'll give you an example. It's kind of fun. There's some people at Stanford a couple of years ago. I can't figure out if they did it, just to kind of be mean-spirited, or if they just did it for fun. It's a pizza ontology, and if you just Google pizza ontology, it's there. It's huge. It's just like pages and pages of XML, and it just describes everything a pizza could do and still be a valid pizza. So if you took a hamburger, there's no way it's going to comply with the pizza ontology, because it doesn't have like all these properties, all these relationships between objects like cheese and toppings and stuff. So we'll use semantic pizza because it's a little bit fun, and this stuff is really excruciating. So thinking about linkage, one key thing about linkage is a resource that's always there. And this is one key thing about Ethereum that we have this great advantage. We have a permanency here. And the current web, like so much semantic web data, web pages, everything just vanish within a couple of years. Once that business goes out of business, poof, But there's potential for our ecosystem to provide the permanent linkage. And so here's some things you might be familiar with from HTML. You see these XML namespaces. This is how you refer to things with semantic web data. And you can see this is RDF right here. I don't even want to go into how RDF is structured and why it does what it does, but this kind of gives you a notion that it's linking to things out there, and you can see how it's defining these namespaces. You see there, there's pizza, referring to the location of the pizza owl, which is an ontology. An owl follows an ontology. And so if you go to that location, you'll just see this giant chunk of text of the pizza ontology. So you think of descriptive meaning, types and properties, much like a database, a database table. So think about assertion about Los Angeles. This is the RDF format. It comes in triples. And so Los Angeles is a type of city. This is how you would tell a semantic web aggregator or query about Los Angeles is a city. That thing in the middle there, you have to say it this way in RDF. Now, here's an ontological assertion about pizza. A topping is a property or ingredient of a pizza. And there's actually, I'm certain somewhere in that pizza ontology there's a line in RDF that says that. Here, this is a chunk of XML that would talk about descriptive meaning. There's actually like a schema describing the notion of type. There's schemas for everything in the semantic web. Everything you can imagine, starting with, there's probably even one for nothingness. So structural meaning, the relationships between these different objects that we've described. So I'll take one that's a little more exotic, transitive property of ingredients. So the ingredients of ingredients are ingredients of the whole. And, with pizza, who cares, right? But, if you're writing if you're writing an application, you want valid data to happen. This comes in handy, and so there's in this OWL standard, there's tons and tons of these sorts of things like transitive property, and it all stems from that field of I don't even know the name of it, ontological studies. There's a field of study for this stuff, and they have a whole world of vocabulary for it. And so reasoning with the transitive property. So this is a kind of pizza that's fun in Asia. They have, and like Taiwan and Japan, they have these pizzas, and it's crazy. It's like the crust actually has little hot dogs, and there's like little ketchups on top of the hot dogs. I can't believe people would eat this thing, but this is a really good example of a transitive property. It's the ketchup on hot dogs, an ingredient of the pizza. If you would like to compute that, if you'd like to prove that, the semantic web makes it possible. And of course, you go through the reasoning, and yeah, you can prove it that this simple thing right here, that this strange pizza is still a pizza. It's a pizza, even though it's got hot dogs and ketchup, and the ketchup is an ingredient of the whole pizza because of that. And this is just like one of those tiny little corners of the semantic web that kind of illustrates the ornateness of this whole initiative. And there's no way that we're going to do that, and that might be why it failed. But the thing is, this person, Manu Sporny, came along, and he really was a critic of the difficulties of this, and he actually worked on standards of the W3C for many years, and he came up with an alternative. And he's a founder of Digital Bazaar as well, by the way. So he's a very interesting person. And so he wants to reform RDF. He would like to add this ability without all the work. And so he developed this thing called JSON-LD. And JSON-LD is very much more accessible than the ornate RDF, as interesting as it is. Developers can kind of deal with this. All you have to do is put this context in there, and it's a little bit different, but you can get the same sorts of expressiveness without going all the way, just enough. And so this is much more accessible for normal web developers, and I think that this is an opportunity for Ethereum to actually participate and construct something along the lines of a semantic web. And so why would we do this? Why would we use this not failed, but not known to the public and not fully expressing Tim Berners-Lee's full vision of what he wanted to do? Why would we use this? So the key is our data in our systems that we're going to be building is potentially forever. And you don't want it. You have to think to the future, and you have to think that people are going to be looking at this and trying to figure out what you're trying to do. And the weirder your solution, the less conformant to standards it is, the more difficult it is going to be in the future. And you can cooperate on developing these ontologies. If you have very lightweight ontologies, you can work with other developers, and then you don't have to keep redoing the same stuff in the various DApp objects that you're dealing with, users and all these other things. And the key, especially with Ethereum, because it has the trust, it has so many of these features that weren't present when Tim Berners-Lee was coming up with the semantic web. We're developing ecosystems so rapidly, it's amazing. But if we had more structure, we could do so much more. And one interesting thing about Ethereum is we have tons of metadata already. And ERC20 is a really good one, ERC735. Even documentation, that's descriptive metadata. And the key about structural, like in the semantic web, there's ways to validate. But in our system, it's much more rigid, and that's a good thing. They're either forced by the EVM or they're enforced by your Dapps. And so, how might we go about it? Obviously think about it, just go light on it. Stick with things that that's accessible to developers. And one key thing that was really bothering me, like in the last couple of weeks before I'm giving this now, is like, how do you incentivize people to do this? It's more work. And if there's something here, it's going to be from that, those additional new layers. And because of Ethereum itself, you can get paid. And that's going to be very interesting. The future ecosystem built on top of your thing, you get revenue from that. And so like the key recommendations, let's stop repeating, like reinventing all these different common objects, create schemas that are known and shared. And there's this schema.org, it's a really interesting resource. Basically, they've packed it in with all kinds of common use objects. And JSON-LD very commonly refers to it. Many semantic or metadata things refer to it. And this is fun to browse. There's all kinds of things. I don't think there's pizza in there. They missed that one. And obviously with Swarm, put the JSON-LD on Swarm and then refer to it in contracts. And the JSON-LD in Swarm, just have them refer back and forth to each other between the contract and Swarm, the data on Swarm. And you know, you can get the highly structured benefit, more expensive benefit of contracts, and then just the immense storage capacity of Swarm and IPFS. And so, like, if you think about the lessons, I guess I'm repeating myself, don't burden the developers, build things for ecosystems, and take a look at the W3C standards. There's many of them, and they are a little bit of a, you know, rabbit hole. Like some of these standards, like OWL, you go down the OWL rabbit hole like I did back in 2000, whenever, and you know, I didn't come out for a while. You know, I wouldn't recommend it too much, but I think it's very important to go and review what's already been done out there, as opposed to just kind of like, hey, I'm just going to build this thing, and you know, like someone else is going to build the same thing, or practically in a different way. Learn from the greats, and they did a lot of great things. They overdid it, but they did a lot of great things. So that's it. If you guys have any questions, I'm interested. Yeah, I built this presentation in HTML, by the way. It's kind of cool, reveal. So that's it.
Yeah, you were talking about schema.org and to build Ethereum's schema.org. How would it be different, and how would you? Where do you publish the schema of your metadata?
Yeah, you would create a Swarm resource for schemas. Like you would just pack, like I would see that you'd create a system of contracts so that you could version different schemas that you would develop. And you can host all the schemas as JSON-LD or as just OWL files, traditional OWL like ontology files. And you just put it on Swarm, put it on IPFS. And you could just mirror schema.org and then just encourage people to refer to it. Like if they're going to declare person, make sure they say, this is a person according to schema.eth, or whatever it's going to be. And so that's what I would think. It would just be filled with lots of ontology documents. And then contracts to maintain that system for versioning and just control.